In this video, you will learn about graphing absolute value functions. First, let's begin by discussing parent functions and transformations of those functions. A parent function is the simplest form in a set of functions that form a family, and each other function in the family is called a transformation of the parent function. And as we can see below, we start with our original graph, and then we can somehow change the function to create all the others. The function that we're going to be discussing is called the absolute value function. In the absolute value function, if we were to plug in -2 into the equation, it would be the absolute value of -2, which gives us +2. We repeat this process, and it ends up giving us this V-shaped graph. Now let's discuss parts of the absolute value function. The vertex is a point where the function reaches the maximum or minimum value. And in this specific case, the vertex would be at this point right here. Now the axis of symmetry is a line that divides a figure into two mirror images. So our axis of symmetry in this specific example would be our y-axis, and we represent it with a dashed line. Now we're going to use this information to graph our absolute value functions. But first, let's review the steps. The first step is that you are going to locate and graph the vertex. Then you're going to graph the axis of symmetry. Next, you're going to use the slope to graph the right side of the graph. And finally, you'll reflect the graph to the left side of the axis of symmetry using corresponding points. Now, the general formula we're going to use for graphing our absolute value functions is y equals a absolute value of x minus h plus k. The a stands for the slope of the right side of the graph. The h represents the x coordinate, and remember to switch the sign since it's at minus. And then lastly, the k represents the y coordinate, and remember you're going to keep the sign the same. This relationship is based on this general formula. So if it's the h, you switch the sign, k, keep the sign. Now let's practice graphing these absolute value functions. First, we're going to rewrite the absolute value function in standard form. It becomes y equals, since there's nothing in front of the absolute value, it's really a 1, times the absolute value of x minus 2, and then since there's nothing at the end, it's really plus 0. Now from this, I can decide that the vertex is going to be the opposite of the h value. So since the h is -2, it becomes +2. And then the y coordinate is the k value, which is 0. And I can plot my point on the graph. Next, you're going to draw on the axis of symmetry, which is a vertical dotted line through the vertex. Then we can determine that the slope of the right side of the absolute value function is whatever is in front of the absolute value. So in this case, it would be 1, which is really 1 over 1. So I can plot my point. So I can go up 1 over 1 and draw in the graph of the right side. Now the last step is to reflect this onto the other side of the equation over the axis of symmetry. So I can put my reflected point and draw in the left side of the function. Take a minute and try the next example on your own. Now, to complete this example, let's first rewrite it in that general form. So it'd be y equals, since there's nothing in front of the absolute value, it's really 1 times the absolute value of x plus 1, and since there's nothing after it, it's plus 0. Now the vertex is going to be, the x coordinate is going to switch, so the h is the x, so since it's +1, becomes negative 1, and the k value is our y-coordinate. So our k value in this case is 0. So I can plot my point at negative 1, 0, and draw in my axis of symmetry. Next, I'm going to use the slope to graph the absolute value equation. So my slope of the right side, in this case, is going to equal 1, which is really 1 over 1. So I'm going to go up 1 and over 1, and then I can draw in my line. Now I'm going to reflect this over the axis of symmetry. So since I have a point right here, I'm going to draw in my corresponding point on the other side. So I will plot the point and draw in the other side of the V. For our next example, we're going to go through the same process. So first, let's rewrite our absolute value equation using the general form. So it becomes y equals, since there's nothing in front of the absolute value, is 1 absolute value of x, and since there's something else inside, it's minus 0 plus 4. Now from here I can say that my vertex will be the x-coordinate, which is the opposite of 0, so it's just 0, and the y-coordinate, which is k, which is 4. So I can plot my point at 0, 4. And I can draw in my axis of symmetry. Next, I'm going to take the slope from the absolute value equation. So the slope of the right side will be whatever is in front of the absolute value. So it's 1, which is really 1 over 1. So if I graph the right side of my equation, I'm going to go up 1 and over 1, and then I will draw in my line. Lastly, I need to reflect this over the graph. So if this is my original point, my reflected point, since I'm going to go over 1 unit to the axis of symmetry, plot the other point, and draw in the other side of the graph. Pause the video and try the next one on your own. For the next example, let's first rewrite it in our general form. So it becomes y equals, there's nothing in front of the absolute value, so it's 1, times the absolute value of x, there's nothing else in the absolute value, so it's minus 0, and then minus 3. Now the vertex is going to be the opposite of the h value, so it stays as 0, and then it's the k value, so it's minus 3. And I can plot this point. Then I will draw in my axis of symmetry as a vertical line through the point. Next, from the equation, I can tell that the slope of the right side is going to be positive 1, which is really 1 over 1. So I can graph the right side of my equation. So I'm going to go up 1 and over 1, and I will draw in the right side of the graph. Then, lastly, I will reflect this point over the graph. So I reflect it onto the other side and draw in the left side of the absolute value function. For the final example, we are going to combine both the vertical and horizontal transformations into one graph. So first, let's rewrite our equation in standard form. So it's y equals 1 times the absolute value of x minus 2 plus 1. Now from this, the vertex will be at, it's the opposite sign of that h, so instead of being minus 2, it's plus 2 as the x-coordinate, and the y-coordinate is the k. So it's 2, 1, which I can plot on my graph and draw in the axis of symmetry. Then I'm going to take the slope from the equation. So the slope of the right side is going to equal 1, which is the same thing as saying 1 over 1. So I'll go up 1 and over 1 to the right, and then draw in the line. Lastly, I'm going to reflect this over the axis of symmetry. So I can reflect this point and draw in the left side of the function.